Hello everyone, let's quickly learn how TLS Handshake is made in Windows. First of all, why need TLS Handshake? When client connects with the server and exchanges the data on the fly becomes vulnerable. Someone in the middle might intercept and access the data. To prevent this, TLS protocol has been created, which helps to encrypt the data on the fly. As a result, only server and client can encrypt and decrypt the data, and man in the middle cannot read it. Okay, so to establish this TLS encrypted connection, server and client should initially make TLS handshake right after TCP handshake, and they should exchange the data. So how this TLS handshake is made? TLS handshake starts with a client hello message, which includes TLS version and cipher suites supported by the client. Also, this message includes the client random, which is a string of random bytes. In response, the server sends back server hello message, which contains server's chosen TLS version, and cipher suites and server random, which is another string of bytes. Also, server submits its SSL certificate. Then, client enters certificate verification phase to validate the server's identity. How this verification is made in Windows? Each certificate submitted by server includes information like domain name, organization name, certificate authority who published this certificate, and digital signature, expiration date, etc. One important point, this digital signature is encrypted data which validates this all information. In other words, if you decrypt this digital signature says, okay, this is correct domain, this is correct organization, this is issue date, something like that, okay? This data has been encrypted by CA's private key and can be only decrypted by CA public key. This is very much important. In the meantime, Windows client has list of trusted certificate authority and their root certificates. These certificates include CA public keys, which can decrypt this digital signature of corresponding certificate authority. Let's say DigiCert Global Certificate Authority provided you a certificate. So in your certificate, the name of this authority is mentioned. When this Windows client machine gets this certificate, it directly finds this authority in the list and gets its public key and decrypts this digital signature. After decrypting this digital signature, client is able to verify the server and all the information given in the certificate like domain name, organization name, etc. If the given information is matching what is stated in the certificate, then certificate verification phase succeeds. If client cannot find authority in its list, or it cannot decrypt the data, or decrypted data is not matching with the given information in the certificate, verification fails and client closes connection. This list of authorities is generated by Microsoft and constantly updated by Windows Update. Furthermore, you can also change it by yourself by adding or removing certificates. Let me show you this in my machine. Firstly, we go to mmc.exe certificate store. Here, you can see all the installed certificates. Let's double click here, the second certificate. I'm sorry, due to some privacy issues, some parts of this presentation is blurred. After clicking, you will be able to get different information about certificate along with certificate authority name. Okay, this is a certificate authority name. Now, let's check whether this certificate can be verified by client. You go to client, the same location, but this time you choose Trusted Root Certification Authority folder, not personal folder, okay? Here you can see that the same authority exists. This means that client can at least find the public key for the certificate and can possibly verify the certificate if the certificate is truly provided by this authority, okay? If you want to see the public key of this authority certificate, you can just export the certificate first. Then, after exporting, you just run this PowerShell command to see the details of the certificate. In the details, you can see the public key like this. So let's get back to the steps. Suppose verification passed. Next step is passing premaster secret. Client generates and submits premaster secret, which is a random string of bytes. This secret is encrypted by public key in SSL certificate and can be decrypted only by server which holds private key. Then by using server random, client random and premaster secret, session key is generated in both client and server machines. Finally, after generating session keys, client and server send finished messages confirming that session key is generated, and the TLS handshake finishes with this. After this, all the exchanged information, database client information, are encrypted with these session keys. Let's see this in NetSH traces. This is a trace which I'm checking with Wireshark. As you can see, the first client hello is happening, where client is submitting its supported TLS version, random bytes, and its list of supported cipher suites. Then server hello is happening. Server is also submitting its chosen TLS version, random, and its chosen cipher suite. Also, you can see certificate information also here. Then other steps are submission of encrypted premaster key, this encrypted data, and also session key generation. After session key is generated, all the data being exchanged, it's encrypted. So therefore you can see encrypted data and application data messages in Wireshark.